everyone. In the last video we saw about the unit and the fundamental unit, also known as base unit, and how to define the fundamental unit. So today we will talk about the dimension of physical quantity. In our previous video we saw that 7 base unit, and based on these 7 base unit we can define any physical quantities. So any physical quantity can be defined as the product of different power of base unit. So if we consider our base unit like m for mass, L for length, and T for time, and etc. So dimension we define for any physical quantity. Let's consider the example 1 is force. Force is nothing but the mass time acceleration. Mass times acceleration, and also this acceleration is nothing but the velocity divided by time. Also this velocity also we can define as mass. Velocity is nothing but length divided by time with multiply by this time. This is the unit of the force, mass multiply length divided by time, right? Time into time. So time square. So it is also, we can write as mass multiply length divided by time whole square. Okay. And in our previous video we discussed about that. For simplicity we use m for mass, L for length, T for time. So in that case if we write force, the dimension of force F over C, this is force, and the square bracket represent the dimension of the force, is equal to nothing but mass m, length L, and time square. It is in denominator, so if we take to numerator then it will be minus 2, T power minus 2. So this is the dimension of force. So in force there is only 3 base unit, but as we have 7 base unit, all the other base unit like current, temperature, in that case all this is like, we can also write it m, L, T power minus 2, I for current power 0, K for temperature, Kelvin power 0, similarly for mole power 0, because these base quantity are not present in force. So in this dimension of they are not present, so we will write as power 0. And the intensity was luminosity intensity, CD power 0. So this is the full dimension of force. So what is dimension? Dimension is nothing but the exponent of the base quantity which represent the physical quantity. So this is the unit. This is the unit of force, and if we write in short form using m, L, and T, the exponent of this base quantity is the dimension of force. So next question comes, what is the uses of this dimension? So what are the uses of dimensions of physical quantity. What are the uses? First, to check the homogeneity of equations, we need dimension. One is to check the homogeneity. Homogeneity of equation. And next uses is conversion of unit. If we are working on SI unit, we need some CGS unit. What is the physical quantity like force in CGS unit? So in that case we need help of this dimension. And third is deducing the relation between physical quantities. Deducing relation among physical quantity. Okay. So first we will see to check the homogeneity of equation. So let's consider a equation A B plus C equal to minus of D. In this kind of equation, these are all our some A, B, C, D. These are all physical quantities. So to check the dimensionality, dimension should be A multiplied B is equal to dimension of C is equal to dimension of D. Because we cannot subtract with different dimension physical quantity. So we can only subtract the physical quantity with the same dimensions. So in our school level we have seen a equation, famous equation, x is equal to ut plus half at square, where x is the length, u is velocity, t is time, a is acceleration of particle. So in that case, in this equation, all terms should have same dimension. Like this is x, dimension is length. Similarly for this term ut, this term should have dimension of length. Similarly for this half at square, these terms must have the dimension of length so that we can add it. So as we know, dimension of x is length L. What is dimension of ut? U is velocity, and the velocity we know that length divided by time multiply t is time. Time will cancel from denominator and numerator, and it will remains length. So it is also length. Dimension of ut is length. Similarly for dimension of half at square, in that case, as we know in our previous video, the physical quantity have no dimension, that is why it is dimensionless. So the acceleration, we know acceleration is velocity divided by time, and also t square is nothing but time square. So time multiply time. So one time is numerator and one time is denominator. So one will cancel and remain 1. So velocity multiplied by time, which is nothing but the u into t. So this dimension also have, this is also have dimension of length. So in this equation all three terms has dimension of length. So we can add these three terms. Next is conversion of unit. If we choose different set of base unit to work, that in that case all quantities should change their base unit. Let's understand it by taking an example. One is SI unit, we know, and another is CGS unit. What is CGS unit? CGS unit is length, mass, time. So length in centimeter, mass is in gram, and time in second. This is the CGS unit. And what are these three quantities in SI unit? In SI unit, length is in meter, mass is in kg, and time is in second. So if we want to convert from meter to centimeter and kg to gram, then we need to convert all the physical quantities unit. So let's consider physical unit, pressure. What is the unit of pressure and how do we define the pressure? Pressure is nothing but force per unit area. So what is the unit of dimension of force? As we discussed before, dimension of force is m l t minus 2. And what is the dimension of area? Area is nothing but length multiplied by length. So L2. This is the dimension of area. This is in denominator. If we take it to numerator, then it will become m l. Here it is, its power is 1, its power minus 2, l minus 1, t minus 2. This is the dimension of pressure. So using this, we can define the unit as mass kg multiplied by, all are in minus power, so kg meter second square. This is the unit of pressure. So if we want to convert this kg and meter to CGS unit, from SI unit to CGS unit, then we need to convert this kg to gram and meter to centimeter. Okay, so this is in SI unit. If we take CGS unit, we need to convert kg to gram. So we know 1 kg is equal to 1000 gram and 1 meter is 100 centimeter. So what will be the unit of pressure? Pressure equal to kg. In place of kg, we will put gram. So 1000 gram divided by meter. What is meter? In centimeter, 100 centimeter. And in time is second. In SI unit also it is second, and in CGS unit also it is second. So second square. So 1000 divided by 100, these are constant, they don't have dimension, so we can divide them. So it will be 10 gram centimeter into second square. So which is the larger unit? SI unit. because 1 SI unit of pressure is equal to 10 times CGS unit of pressure. Also in SI unit, pressure is known as Pascal. This is the unit of pressure. So next use of dimension is deducing the relation among physical quantities. If we know any physical quantity is related to some another physical quantity, then we can deduce the relation among these physical quantity by using the dimension analysis. So we will understand it by taking an example of simple pendulum. Let's consider a simple pendulum is connected to a loop. Its mass is m, the length of this string is L, and it is in earth gravity, so acceleration is g. The value of g is 9.8 meter per second square. Okay. So we know these three physical quantity will affect the time period of this pendulum. So the time period is denoted as capital T, and this time period is directly proportional to the length of the string power A multiplied by mass power B multiplied by gravitational constant G power C. All three physical quantities power is A, B and C. These are kind of dimension. So this is directly proportional to these three physical quantity. So but we know this time period is time and it is a base unit, so its dimension is T. If we make any proportionality with equal, replace with equal, then there is a constant K which is dimensionless and it is present here. The length of the string is L, so L power A multiplied by mass of the string. It is also a base unit mass, so its dimension is m power b. And g is acceleration, and we know that acceleration has dimension of L t minus 2 power c. So this is a equation of, this is the dimensional equation, and we can find the value of A, B and C by equating both sides of this equation. Again we saw that when there is only one base quantity, it means other base quantities power or dimension is 0. So in that case, here is length, mass also present. So in the left hand side, mass power is 0, length power is 0, time power is 1. This is the full dimension of the time period. This is K, and if we multiply all these three, then it will be length power here is A and L plus here it will be C, so A plus C, and mass power B, and time, this is time power minus of 2C. As this K is physical, in this case only constant, its dimension is 0, so there is no dimension for this K. So if we equate separately each dimension, like mass power 0 here and mass power B, these two sides must be same, so B equal to 0. Similarly for length, it is 0, so length power is A plus C equal to 0, it means, and another is for t, here is 1, this side is minus 2c, so 1 equal to minus of 2c, from here we will find c equal to minus of 1 by 2. Okay, if we found c equal to minus 1 by 2, if we substitute here in place of c, then we will get a equal to minus of c, which is minus of half equal to half. So we found all the exponent. A equal to half, b equals to 0, and c equals to minus half. So how time is proportional? Time is proportional to length power a, which is L power half. So next is m power b. So m power 0. It means the time period doesn't depend on the mass of the pendulum. Next is g, gravitational constant. G power c, c is minus half, so minus half. So if we write shortly, this will become time period is equal to k square root of L by g. This is the time period. We saw it is a useful quantity, the dimension is, but there are some limitations for this dimension analysis. One is here like that. We can derive the time period is directly proportional to the length and inversely proportional to the gravitational constant, but here is the constant k. We cannot find the value of k by using this dimension analysis. So it is a limitation of dimension analysis. So here is a question: if two quantities have the same dimension formula, then do they represent the same physical quantity? So comment the answer in comment box. And also, if anyone wants some other topic to make videos, then also they can comment. And if anyone has any doubt, then also feel free to comment. Thanks for watching.